Algebra 2 Mastery Quiz number 5. Probability, round 1. We're going to start off with permutations and combinations. Remember, if order in a problem matters, okay, and we'll look at an example here in a minute, permutations is what we need to use. Order matters. You always have to ask yourself, does order matter in this problem? Or does order not matter? Okay, it can be kind of tricky to pick out which one to use. And remember, combinations, order does not matter. Now remember, with the calculator, we can figure these out really quickly. Okay, permutations, we have N, P, R. Remember, N stands for all the possibilities, or all the possible number, okay? How many there are. That is your total, okay? That would be a better one. That is your total, okay? R represents the how many we are talking about. Okay? And if it's a combination, then it's NCR. Now, to show you that on the calculator really quick, okay, if you go to your math and then you go to probability, okay, we can see both of them. Number 2 right here is NPR and number 3 is NCR, okay, and we'll use those in a little bit. So we're going to get out of this screen, so we can go second quit, remember, to get out of that screen. All right, so let's go and look at some examples. All right, so again, permutation, order matters. Combination, order does not matter. N is the total, all the possible numbers, or how many there are. R represents how many we are talking about. All right, so our first example. In how many ways can a club of 8 members choose a vice president, a president, a vice president, and a treasurer? Okay, president, vice president, treasurer. So we need to ask, does order matter? Okay, well, think about it. Can the person who becomes president, okay, they have to get the most votes. So does that matter? Yes, it does. Okay, vice president, yes. That person got whatever, the second number of votes. And then treasurer. So order does matter. So this is a permutation. Okay, and how many total are we talking about? 8 members. Okay, that first number always has to be the biggest number. Okay, now how many are we talking about? We're talking about a president, a vice president, and a treasurer. So we're talking about 3 people. Okay, so on the calculator, first we have to type the number 8. Then we go math, probability, and we pick number 2, and then 3. So that gives us 336 possible ways that this could happen. Okay? 336 possible ways that we could pick a president, vice president, and a treasurer. All right, the next one. On a test, a student may answer 5 of 7 questions. In how many ways can the student choose test questions? Again, you have to ask yourself, does order matter? Well, if you're taking a test, do you have to take the test in a certain order? Do you have to do number 1 first? Do you have to do number 2 second? Okay? No. I think many teachers will tell you, go do the problems you can do first and then work on the others. So no, you don't have to do, if you only have to do 5 of 7, you get to pick and choose. Okay, so order does not matter. You don't have to do number 1 first and then number 2. Okay, you could start with the last one and then you could do the third one in whatever order you want. So this is a combination. Order does not matter. Again, how many questions altogether? 7. That is our total. That number always has to come first, the big number. And how many are we talking about? 5. All right, so back to our calculator. So type your 7 first, go to your math, probability, and pick number 3 this time. Okay, and we're picking 5 questions to do out of 7. So there are 21 ways that you could choose to do 5 problems. Okay, again, 21 ways. So be careful. Think about the situation and ask yourself, does order matter? Yes, use a permutation. No, use a combination. Okay, and last, a simple probability problem here. Hopefully it's very simple. You randomly select a marble from a bag. Now you're probably wondering, well, why did we just do permutations and combinations, and why are we jumping into probability? Because permutations and combinations are used quite often in figuring out other types of probability problems. Okay, it is in the same unit. So it's important to understand permutations and combinations when we get to more complex problems. But this one doesn't require it. Okay, so back to the problem. You randomly select a marble from a bag. The bag, wow. The bag contains 10 green, 12 yellow, and 18 blue marbles. Put it in reduced fraction or ratios to lowest terms. Okay, reduced fractions, ratios to lowest terms. First of all, how many do we have all together? Well, we've got 10 and 12 and 18, and if I add that up, I believe that makes 40. Okay, so 40 is our total. Remember, with probability, the total always goes on the bottom. All right, and how many of them are green? Okay, well, 10. 10 out of 40 are green. Reduce that. That one you should be able to do in your head. 1/4. So the probability of picking a green marble is 1/4. And that's it.